Okay, so we've learned about derivatives. Well, there's a backwards process to doing a derivative. It's called an antiderivative, okay, which has lots of applications. It's very important in calculus. Kind of learn how to do both ways. So let me explain what an antiderivative is to start with. Okay, all you're doing is I'm giving you the derivative. You're telling me where the derivative came from. Okay, so let's see if you kind of know what I'm talking about. Let's start with this one. What would you take a derivative of that you've learned, and you would get the answer 1 over x?
ln x.
Good, ln x. So that is the antiderivative, is ln x. Okay, so we're just doing everything backwards. Let's do this one because it's super easy. How about this? What do you do a derivative of that gives you e to the x? Okay, so the antiderivative is e to the x. Okay, so we got that. Okay, let's go to these. What would you take a derivative of and you would get 2x?
X squared.
Good, x squared. Sometimes it's easy to do in your head. Okay, so your antiderivative is x squared. How about this one?
X to the third.
X to the third, good. Okay, okay. What's it say it again?
What if we have like x squared plus 2?
Oh, we'll get there. Okay, for now, we're starting simple right now. Okay, because like I said, it's like anything, it starts easy, then it gets more complicated. Okay.
Story of my life.
Yeah, well, that's just the way it is, okay? But if it wasn't that way, life wouldn't be fun, would it? Okay, you like to have a challenge in there. Okay, now here's the idea. You can get more than one answer. So actually, there's a whole bunch of antiderivatives for 2x, because you could have x squared plus 2. What is the derivative of x squared plus 2? 2x plus 0, so it's 2x. Another answer would be x squared plus 3. Same derivative, right? Okay, in general, you would have x squared plus c. Okay, because that's a constant. So you know if you do a derivative of a constant, it's 0 anyway. So this kind of gives you a whole family of antiderivatives. There's not just one antiderivative, there's an infinite number of them. And they're always off by a constant, so you always have to tack in that plus c like that. Okay? All right. So let's look at a couple more of these and look at the notation. The notation on this is more like this. If I give you a function, I'm going to use lowercase f. If I use uppercase f, that's talking about the antiderivative, okay? So what you would do on this is, what do you do a derivative of that gives you 2x? We already did that. X squared. But you also put plus c because you could have a constant. And c just represents any constant. As long as it's a number, that's good. Okay, and the reason is because if you do the derivative of that, well, you just get 2x, don't you? So when you're doing an antiderivative, you can tell you're right. It's easy, okay? Let's see if you can figure out this next one. That's the function. You know what the antiderivative would be? X to the 6th, okay? I'm making them easy right now, okay? All right? Yeah, plus c, thank you. So you have x to the 6th plus c. The reason it's right is because what's the derivative of x to the 6th? Okay, so you're back to the beginning, okay? You undo the process, okay? So that's the idea, and it's actually a real big deal in calculus that you can do these things both ways. Okay, so what we mean by a family of antiderivatives, I've already talked about that. The capital F stands for antiderivative, which is a function. And then the C just stands for any constant. So when you're coming up with an antiderivative, you also got to have that constant, because there's an infinite number of functions that you're going to give that antiderivative. Okay, let's see how many of these we know. Again, I'm trying to keep them fairly simple for now, okay? What would be the antiderivative of 1 over x? ln x plus c. Now, a little picky detail, when you do this, you have to say ln of absolute value of x plus c, and the reason is because you can only do a logarithm of a positive number. Okay, you don't know if x is positive or negative, but you know that if you have a logarithm, you can only do a log of a positive number. What is the derivative of ln x? Yeah, and then the derivative of c is 0, so that just takes you back to 1 over x. Okay, like that. Okay? All right? How about the next one? We've seen this before. I haven't seen it much. What is that? Say it again.
10 to the power of x.
Log? Yeah, it'd be log base 10 of x. Okay, like this. Okay? That one's going to be log base 10 of x. And see what hold on, that's not right. It's 10 to the x plus c. Okay, is that what you said?
Yeah.
That's what I thought you said. I wrote the wrong thing. I'm thinking of the other formula like that. Okay, remember, when we do the derivative of 10 to the x, we said, okay, it's itself, and then what? Times the natural log of 10. Okay, so see, it checks. Of course, the derivative of the constant would be 0. How about 5? Where did that come from?
5x.
5x. 5x, right. If you do the derivative of 5x, you get 5, don't you? So you got the plus c. And again, the reason it's right is because the derivative of 5x is 5, derivative of c is 0, so you're back to the beginning. Okay, those are antiderivatives that you're doing in your head because you know the rules, hopefully. Okay, does that make sense? Okay, go ahead and do the next 3 here yourself real quick. Some of them I've already done. There's only so many of these I can make up so you can do them in your head. I'm going to just kind of... So these you should be able to just quickly do in your head. What's the answer to number 1? Give you x plus c. What's the answer to the second one? Pi x plus c, because the derivative of pi x is pi, right? What's the answer to the next one? Now put the absolute value. Get in the habit of doing that. Okay, so you do that. Okay, those are just rules doing them backwards. And of course, the idea is if you do the derivative of your answer, it just takes you back to the beginning. Okay, that's just wanting you to see that why you're right. Okay, so that's the idea. Okay, that's what an antiderivative is. Now, the plus c idea, I've kind of talked about this. If you can actually graph your antiderivative. So the idea would be like if you had an antiderivative and the constants were different, then it would just be what we call vertical translations. So let's say, for instance, you had an antiderivative of x. Okay, then you had like x minus 1 and x minus 2 and x minus 3. Well, what is the difference between those graphs? They're all lines, but what does this do? That number makes it go up or down, right? And you could also have, remember, you're looking at a constant, so you could have x plus 1, x plus 2, and so forth forever. So if you graphed your antiderivative, it should just be a bunch of curves that are up and down. They've been shifted up. Your antiderivative may look like this. It's a curve, but the point is, if these constants are added, what does it do to the graph? It just shifts it up or down. So the graphs of antiderivatives are just going to look like that. They're just going to be what we call vertical translations of each other. That's the idea. Okay, now I'm going to introduce you to this symbol, what we call an indefinite integral. And we'll kind of talk about what this is, because this is what you learn mostly to finish up the semester in a calculus class is how to do integrals. You've done derivatives. We've done everything we're going to do at derivatives. Now we do it backwards. So when you see this symbol, it really represents a sum. I'm not ready to tell you why that is yet, but that's what that is. It's kind of supposed to be like an S, a stretched out S. Okay, and what this is just a little bit of vocabulary. This f of x, whatever you're doing the integral of, you're doing an antiderivative. That's called the integrand. Okay, just vocabulary. Okay, and then dx is called the differential. I'll get into explaining what that is, but I can't do that until we're kind of learning how to do antiderivatives. So what you're doing when you see the integral symbol, what you're doing is you're finding an antiderivative, okay? So I could ask, like this first problem I'm going to do, I could ask it this way. I could say f of x is 3x squared. Then I could say find capital of f of x. So in other words, you're finding the antiderivative, okay? So what would be the antiderivative of 3x squared? X to the third. So you would have x to the third plus c. All I'm doing is introducing you to the symbol, okay, at this stage. Well, the nice thing about doing an integral is you can always tell you're right. So if you do the derivative of your answer, whoops, what am I doing? Okay, what would be the derivative of x to the third plus c?
3x squared.
Yeah, 3x squared plus 0 or just 3x squared. So you're right. Okay, what's the answer to the next problem? This got a mistake. These variables got to match. So change the x to a t. Okay, so what's the answer? E to the t plus c. The reason it's right is because the derivative of e to the t plus c is just e to the t. Okay, how about the next one?
X
x to the fifth, okay? X to the fifth plus c, okay? So then if we do the derivative of that, what do you get? So see, you're right. Okay, so that symbol, what we call an integral, is it's asking you to get an antiderivative. The plus c is given the family of antiderivatives, okay? Again, if you graphed these, you could graph these on your calculator, and as c changes, all it does is just moves the graph up and down. That's what it is. That's what it looks like. Okay, now, your question over there is, what if it was like this? Okay, so we're going to start getting to that when they start getting a little bit more complicated. The first thing that you generally want to learn on integrals is what we call the power rule. You have a power rule for derivatives. We have a power rule for integrals. So what I'm going to the way I'm going to explain this is kind of like this, okay? The power rule says if you're doing an integral of x to a power, what you do is you add 1 to the exponent, and then you divide by that result. Now, let me explain something about this way. Remember, we're going backwards now. So let me show you let's say that you had something like this. If you were doing a derivative of x to the third, well, what did you learn to do? You learned to bring that down, multiply, I'm going to stress that, and then you learn to subtract 1 from the exponent. Okay? That's how you've learned that. That's the power rule. Now, if we're doing an antiderivative, we're going backwards. So what is backwards of multiplying? Dividing. What's backwards of subtracting 1? Adding 1. So see, we're adding 1 to the exponent, and then instead of bringing that down, we're dividing by that now. Because see, before you were multiplying that by 3, now you're dividing it. So let me show you how this would work. So if you were doing the integral of x to the third dx, well, here's what you do. You add 1 to the exponent. Okay, that's opposite of what you do on a derivative, and then you divide by that result. Okay, so you would end up getting x to the fourth over 4 plus c. That's how the power rule works for integrals. It's real simple. You add 1 to the exponent, and then divide by the result. Okay, like that. I'll do one more, and then I'm going to prove this, and then we'll work a bunch of problems like this. What if you add x to the 10th? What's that? Do it in your head. X to the what? 11 over 11. The exponent goes up 1, and then you divide by the result. Okay, all right? What if you had x to the second? What's that?
X2 over 3.
X to the third over 3. See how it's real easy. Okay, that's how the power rule works for an integral. Okay, now let me explain show you that this is right. So what I'm going to do is anytime you want to find out that you're right on an integral, you just take the derivative of the answer. So you want to write this down. What we're going to do is we're going to do the derivative of the answer. Okay, so we're going to go ahead and just do, let's write this as d dx of x to the p plus 1 all over p plus 1 plus c. If we do this derivative correctly, we should end up with just x to the p. That's what I'm going to try to prove to you. Okay, so we're going to do a power rule on this. So if we do this, of course, you would bring the p plus 1 in front. So you would have p plus 1 times x. You would subtract 1 from the exponent. Remember, what I'm doing right now is I'm doing a derivative. I'm doing the power rule for a derivative. Okay, well, this is a constant. So see, that's already there. So that thing right there is already there. Okay, so see, all I'm doing is this, see, p is a constant anyway. So when you do a derivative, well, you're used to bringing that down, subtracting 1 from the exponent, and then just bringing the constant down. Well, let's see if this works. Those cancel out. What are you left with? X to the p. Okay, so it's right. Okay, so that's how the power rule works. So what we're going to try to do here today is kind of get comfortable with some of the rules for integration, just kind of the basics. Okay? All right, I'm going to work several of these out and kind of look at some of these, and then we'll go on and kind of begin to put the basic rules together. Okay, what you're focusing on right now is you're looking at x to some power. Now that dx there and dt, don't even worry about that. That is notation. I'll explain what that means later. And usually, you're teaching calculus, you can't really get into helping students understand what that differential means until a little later. So what we're going to do on this is just do the power rule. So what we do for integrals, we add 1 to the exponent, then we divide by the result, okay, which is 11. Okay, so what you would get is you would get x to the 11th over 11 plus c. Okay, that would be the antiderivative. That's what the integral is giving you. Okay. Now, what you want to develop the habit of to help you understand this is it's extremely easy to tell that you've done this right. If you want to determine if you have the right answer, just take the derivative of your answer and see if it takes you back to where you began. Okay. So if you were doing the derivative of this, see that 11 there is a constant. That's really just 1 over 11. But then when you do the derivative of x to the 11th, what is that? It's 11x to the 10th. The derivative of c is 0. That cancels out, so it gives x to the 10th. So when you do the derivative of your answer, it should take you back to the beginning.
How does 11 turn into 1/11?
Okay, that's what I was kind of helping you with in my office the other day. If you have x to the 11th over 11, you need to understand that that's the same thing as 1 over 11 times x to the 11th.
I got you. Okay.
That's a constant.
Yes, all right.
Okay, that's fine. I mean, that, you know, the x has a 1 in front, so you need to understand that they're the same. So when you do the derivative, you write the constant, then you do your power rule on that, and then that's how it checks out, say. Okay? Okay, what's the next one in your head?
T to the power 5.
T to the 5th over 5. Good. Okay, so you're just doing, you can do this in your head. Add 1 to the exponent, divide by the result. Okay, there's your answer. Okay, make sure it's right. So if you're doing the derivative of t to the 5th over 5 plus c, well, again, the 1/5, this part right here, this is kind of what you want to make sure you understand. This part is a constant. So you would have 1/5 times, and then what's the derivative of t to the 5th? 5t to the 4th. Derivative of the constant is always 0. 5's cross out, so you're back to the beginning. Okay, so you're right. Okay. Now the next one I'm saying I have careful on there, so that must mean that I'm trying to test your thinking or something. What kind of number is e to the 7th?
Constant.
It's a constant. So, what function would you take a derivative of that would just give you a constant?
0.
No. How about e to the 7th times t? That always bothers students when they see that. See, e is not a variable, it's a constant. The answer to this is e to the 7th t plus c. Okay? How do you do a derivative of like 2t? What's the derivative of 2t? What's the derivative of 3t? What's the derivative of e to the 7th t? E to the 7th. Okay, it's the number in front. That's the idea. So yeah, that's just, if you do the derivative of e to the 7th t plus c, it's just the constant that's in front of t. Okay, don't let that bother you. So that's e to the 7th. Okay? All right, now we get into negative exponents, and you can do negative exponents and square roots. It's all learning the power rule. So when you do this next problem, okay, what happens is the exponent goes up 1, then you divide by the result. So you add 1 to the -2, the result of that is -1. Okay, so what you would end up having is you would just have x to the -1, and it's a negative number because you're dividing by negative plus c. So that would be one way to write the answer is like that. Okay, the exponent goes up 1, then you divide by the result. Okay, now verify that it's right. Now all I'm going to do is just do the derivative of x to the -1 because you know the derivative of c is 0. So let's make sure that that takes you back to the beginning. So how do you do this? You just bring your power rule would be -1 times -1 would be 1. Then you would subtract 1 from the exponent, so you'd be back at the beginning. So it's verifiable. So once you get your answer to your antiderivative, take its derivative and see if you're right. Does that make sense? Okay, it's just backwards of doing a derivative. It's adding to the exponent and dividing by the result. That's opposite of what you did. So let's see, when you're doing this one, you would want to change this to x to the 1/2 dx like that. So you're finding the antiderivative of that. And we're doing the power rule. So when you're doing the power rule, you're going to do this. You're going to add 1 to the exponent, but it would be wise to use 2/2, right? And then you divide by the result, what is a half plus 2 halves? 3 halves. So you're going to divide by 3 halves. Then you're going to have your plus c. Now you want to clean that up. If you divide by 3 halves, what are you really doing? How do you divide by a fraction? You multiply by the reciprocal. So this is really multiplying by 2/3. So when you're doing this, you're going to learn to say, okay, I'm dividing by a fraction, so really I'm multiplying by its reciprocal. So you would have 2/3, then you would have x to the 3 halves plus c, and then that would be a good way to write the answer. You could change that back to a radical if you needed to, but that would be it. Okay, so if you got radicals and you're doing an antiderivative of a radical, write it as an exponent and then apply the power rule, because that's all you know right now is the power rule for integrals. That's it. Okay, now let's see if this checks out now. Okay, so let's do the derivative of the answer. Forget about the c, because that's going to go to 0 anyway. Okay, so you've learned how to do a derivative of that. So if you do a derivative of this, you're just going to write down the constant 2/3. Then the power rule you're going to use on this, so it's going to go like this. You're going to bring the 3 halves down. Then you're going to subtract 1 from the exponent, so I'm going to use 2 halves. And hopefully we get back to x to the 1/2. Well, what happens there? That crosses out, that becomes 1, okay? Then you have x to the 1/2. So you're right. Okay? Learning how to check your answer on an integral helps you understand what an integral is. Okay, does that look okay? Okay. All right, this one you got to be really careful on, okay? Now watch this real carefully. If you're not paying attention on this, you might think to do this, okay? If you did the power rule, what you would do is you would add 1 to the exponent, then divide by the result. Is that okay? You can't divide by 0. You can't do that problem that way. It doesn't make any sense to do the problem that way. Instead, what you have to do is you got to do this. Is there another way to write x to the -1? Exactly. You can write it as 1 over x. Remember, you can change that to 1 over x to the first, right? So you could write this as the integral of 1 over x dx. Well, what's the answer? Yeah, okay. What do you take a derivative of that gives you 1 over x? An ln. So the answer is ln of x plus c. Okay, you can't, if that's -1, you can't, the power rule does not work when the exponent's -1. It doesn't make any sense. So one thing you'll kind of see on the definition of the power rule, I'm going to go back here. See, notice it says that that exponent cannot be -1. It can be anything else, it just can't be -1. Okay? Okay, so let's see. Let's go through some of these things where we kind of put these together. And I'm going to kind of give you some rules that we do here. We want to kind of get through these 2 rules. This works the same way derivatives do. So if you have an integral and you have a constant times a function, then that can be moved out of the integral. Okay, like that. So you might want to write this down at the side. An example of this would be like if you had 2 times x to the 3rd dx. Okay, this is what this is showing you. So if you have a function and then a constant, what you can do is just bring that in front. Okay, and then you're going to do the antiderivative of x to the 3rd dx. Okay, that's how you're going to do that. Now, when you finish this problem, okay, what you would do is you just bring down the 2. Now, what is the antiderivative of x to the 3rd? By power rule, what is it? X to the 4th over 4. Okay, add to the exponent, divide by the result. So the antiderivative of that is x to the 4th over 4 plus c. And of course, you could simplify the 2/4. You could reduce that fraction to if you wanted to there. You'd need to do that. Okay, so that's the idea. What I'm showing you is if you're doing the integral of a constant times a function, bring the constant out. That's like you do limits. Okay, it's the same thing. It all comes from a limit anyway. Okay, what this one says is the sum rule. Now, this could also be minus, so it's not a bad idea to just kind of put a plus or minus there. An example of this would be, say you have the integral of x squared minus e to the x dx. Okay, I'll keep it simple. So if you're going to do that problem, now you can do this in your head, but technically what you're doing is the integral of x squared minus the integral of e to the x dx. That's what you do on derivatives. You just do each part separately, right? Okay, so what's the integral of x squared? X the third over 3. We're not doing derivatives, we're doing integrals. So that would be x the third over 3, and then how about e to the x? Plus e, that's it. So what you're doing is if you have a function that's added and subtracted, just do each piece separately, just like you do derivatives. That's the same thing, okay? And just kind of to help remind you of this, like if you were doing the derivative, keep this simple. Let's say you were doing the derivative of ln x plus x squared minus e to the x. What did you learn how to do? You learned to just do the derivative of each part, right? And then just do the signs, right? It's the same thing, okay? So when you have an integral of sums and difference, you just do the integral of each part. Does that make sense? Okay. Okay, let's work some problems out on this next page, and this will kind of go over some of that stuff. Okay, so what happens on this one is there's two ways to do this. One way to do this is just do it in your head. Okay, what would you take a derivative of? That would just give you 2.
X squared?
No, 2x. Okay, yeah, 2x. The derivative of 2x is 2, right? So you could just do this in your head. That's 2x plus c. Okay, you can do that. Okay. Now, if you check it, you would do the derivative of the answer. And what are you hoping you will get? 2. Okay, that's where the problem started. So is that right? Yep. Okay. You do the derivative of 2x, you get 2. You do the derivative of c, you get 0. Therefore, you get 2. Okay. Now the next problem, we're going to use the rule. You can, when you do a problem like number 2, you can do it in your head. Okay, I'm all for that, but I want you to write it like this. We're going to do the integral of z squared dz, put the dz there, plus the integral of 3z dz, and then minus the integral of 10 dz. Okay, that's the basic rule that you have for integrals. So if you're doing an integral of sums and differences, you just do each part. Okay, now before I do this, I'm going to do one other thing on here. You can kind of bypass this stuff once you get experience with this, but that's a constant, so that can come out. So before I do the integrals, I'm just going to rewrite everything. Then I'm going to write this middle one as 3 times the integral of z dz minus the integral of 10z. Now you're going to end up, when you start doing integrals like this, you're going to do this problem in your head 100%, just like you do derivatives. But that's the reason why you can do that. So what we want to do is we want to do each of these integrals and then kind of simplify our answer. Okay, and all we know right now is the power rule and just real basic antiderivatives. All right, use the power rule for z squared. What are you going to get? Z to the third over 3. We're not differentiating, we're doing integrals. So that is z to the third over 3. Don't put a plus c until the very end of the problem. Okay? Now on this, you're going to bring the 3 down. Okay? Now this right here is also a power rule. That's z to the first. So what is its integral? Z to the second over 2. Okay? So that will be times z to the second over 2. Good. Okay? Okay? Don't forget this one. What would you take a derivative of? That would just give 10. 10z. Okay? Now put your plus c. You don't need to put a plus c after each integral. That's just one big plus c for the whole thing. Okay? So then I would probably clean up the answer like this. You can write it this way. It's okay to write that way. It's also good to know that this is the same thing as 1/3 z to the third. That's kind of the preferred way to write that. And then this here is 3 halves. So you'd have plus 3 halves, c to the second, minus 10z, and then plus c. So that would be the answer to your integral right there.
So 10 dz, how does that turn into 10z?
Because remember, what you're doing is an antiderivative. The idea is, what do you take a derivative of? It just gives you 10. See, if that's a constant, all you do is just tack on the variable. So like if you were doing the integral of 5, it would be 5z.
But if there's a square root exponent, you have to do the...
You got to use power rule, right. Okay, yeah. Okay, let's see if this is right. Okay, so let's go ahead and just do the derivative. Let's just kind of do this in our head. So if we did this, we'd have 1/3. The derivative of z to the third is 3z to the second. Okay, do the derivative of the next part. Okay, you have a constant, so you write it down. The derivative of z squared is 2z. What's the derivative of negative 10z? Negative 10. Of course, the derivative of the constant 0. Now remember, what we're trying to do is see if we get back to the beginning. So notice the 3's cross out, the 2's cross out, and now what we're left with is z squared plus 3z minus 10. Now that plus c should have been a 0. So it's right, isn't it? So what I do is I take the derivative of that answer. It should match up with where I began. Okay, is that okay? Okay. All right, let's close off maybe with doing this, these next two here. And that will kind of get us through a lot of the basics we want to do today. Now, what do you think you should do with a radical if you're going to do an integral? Change it to a power. Okay, so we want to change this to the integral of 2x to the 1/2 minus 10 over x to the 1/2, and then that whole thing dx. And dx is notation. Just that's got to be there. Don't worry about y for now. Just got to be there. Okay, now what we can do on this is we can break this up into two integrals. So what you can do is do this integral, and you can do this integral. So I'm going to do this. I'm going to do integral of 2x to the 1/2 dx minus another integral, which is 10 over x to the 1/2 times dx like that. Okay, and I want to kind of write all the steps on this as you're learning this. So this is a constant, so constants can be brought outside of an integral. Okay, that way you don't have to worry about those. So what I'm going to do is I'll move it over here. You'll have 2 times the integral of x to the 1/2 dx. Okay, then we'll bring out the 10. Now the other thing is, this thing right here needs to be brought to the top because it's got to say x to a power. So what, if you bring it to the top, what is it? X to the negative 1/2 dx. Like that. Okay, that's how you got to put this together before you're even ready to find your antiderivative. So you got to do that. Okay, so let's put this together now. Now we're ready to use the power rule. The 2 comes down. Okay, now when you do this integral right here, now you're using the power rule for an integral. So you're going to have x to the 1/2 plus 1. Now use 2 halves. Okay, you're adding 1 to it. What is a half plus 2 halves? 3 halves, right? So you're adding 1 to the exponent, dividing by the result. Okay, now let's go to the next one. We have minus 10 is a constant. Okay, carefully do this. This is going to be x to the negative 1/2 plus 1. So you're going to use 2 halves, right? Okay, what are you going to divide by? The result of that exponent is a half. So you do that, then you have the plus c. Okay, so again, what you're doing, don't let the fractions bother you. You're adding 1 and dividing by the result. Now, I don't want an answer like that. It's too messy. So what you want to do is this first part, you have a constant 2. If you divide by 3 halves, what are you doing? You're multiplying by 2/3. Dividing by a fraction is the same as multiplying by a reciprocal. Okay, then you have x to the 3 halves. Like that. And you can just leave that as a fractional exponent. That's fine. And then same thing here. You have the minus 10. If you divide by a half, what are you really doing? Multiplying by 2, right? Okay, then you have x to what power? 1/2. Okay, plus c. Okay, so I'm doing some arithmetic. Anytime you divide by a fraction, you're really multiplying by a reciprocal. You can bypass that step. If you see you're dividing by 3 halves, you can jump into this immediately. So then the final answer we write like this. You can put this straight across. That would be 4/3 x to the 3 halves minus 20 times x to the 1/2 plus c. Like that, that's your answer. It can be checked. Okay, I'm not going to take the time to do that, but you could go through and do a derivative and it'd take you back to the beginning anyway. So that's it. Okay. Okay, so this is what you're going to be doing the last couple of weeks here, is doing lots of integrals. Okay, this is just kind of the beginning, and then we'll kind of learn the applications of them in 2 as well, okay?